Continuing for 4.5, now dealing with a real world equation. This one deals with sports, so shout out to all the volleyball players, all the baseball players, all the softball players. I see you. So we're given this equation here, which is modeling a baseball throw, where f of x gives the height of the ball and x gives the distance from where it is hit in feet. This is kind of important based off of the units, because eventually when we go back to our answers, we'll want to answer these correctly. I use the ridges motion for this, so if you need to reread this problem, do so. I already interpreted what's important. I have this equation. I know that the height y legitimately is representing the height of the ball, and x is giving the distance from where the ball is hit and how far it goes. I've already drawn a diagram seen here where this poor sketch here on the side is f of x, so the height. Our goals are seen here, so a few details that we want to find out. We want to find out how far the ball travels before hitting the ground. So as far as how far this goes along the x-axis. We also want to see how high the ball goes, so how far in the vertical direction. And also going back to domain and range, where domain is going to tell us x values that make sense for this parabola in this real world context, and also y values which correlate with the range. So a little bit of vocab here coming back again. If I taught you previously, you might be able to recall this drawing here for Dr. XY. This is a convenient way to remember which coordinate the domain correlates with. So domain correlates with x, range correlates with y. Kind of looks like a doctor's hat. So you can use that in the future. I was trying to use the TI-84 Smart View for this, but it kept crashing and said there was a syntax error. So we're going to go with desmos for this. So imagine that this is the baseball throw. We could also throw in a picture here if we wanted to, but we're really just concerned about how this is being thrown. And of course, this is in feet. So the first question was asking us how far the ball travels before hitting the ground. Well, we know that it starts at 0, 0. It will continue going through this path. And then ideally, if it has gone the full distance vertically, it's going to end up back on the ground again. So this point here is really crucial. We'll amplify this a little bit more so we can see it. So this point here, this 385, 0, is one of our answers. So we know that the ball in particular will travel 385 feet. We'll also make this a note so that we can actually see it fully. Cool, so we got that part down. As far as how high the ball goes, what do you think for that? What point on this path do you think is going to be the highest point? Hopefully you're saying the vertex. This one's pretty easy to spot. So our vertex seen here is going to be 74.112. So the highest point. Of course, making this a note so that we can see everything. We'll call this the path slash the ball because this is a context that is relating to a real world circumstance. So after 192.5 feet, the ball goes 74.112 feet high. The final question asks us about the domain and the range for this type of function. So what do you think? What are going to be the valid statements for this? What's nice again is that we can change this. So remember that the x-axis was dealing with the distance from where the x is dealing with where the distance from where it's hit, and the y-axis was dealing with the height of the ball. So what domain and range values do you think make the most sense here? Well, we don't want to go negative, we wouldn't want to go down a negative number of feet unless we were doing something real bad. You never want to go below the ground unless you're working on roads or working in construction. So we could just say that from 0 to 385, that's a pretty good domain. That's all above ground. So we'll make a note of that, keeping it as a note. Using brackets on this because we want to include 0 and we also want to include 385. And for the range, keep in mind that this was starting at the height of 0, which is kind of goofy because that's implying that, or no, well, I guess it could work. I guess I'm thinking of the height of the ball. That's different versus the height from the person who threw it. So the range in this case would be from 0 to our highest point, which in this case is 192.5, 74.112. So we could say this is from 0 to 74.112. Pretty solid. Relates to the context. We see that every little bit's hit. And I think that it's really important to relate the material to the context when possible. So please, if you need to, graph these out on Desmos. Use a calculator if you need to. This is another interpretation, another way that you can graph this out. And this is all at desmos.com.